Yeah. Yeah. Good evening, all. So myself, I'm Vijay. I hold like 15 plus years of experience, which includes nearly 8 plus years of experience in big data, Hadoop, and Spark. So as part of today's demo, I'll be covering the following topics. Right. What is big data? Why Hadoop? Why Hadoop and Spark? Why Hadoop and Spark? Why Hadoop and Spark? Right? So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right? Can anyone please confirm whether the voice is clear, whether the screen is visible or not? Drawbacks with the current databases. Drawbacks with the current databases, right? Yes. So what is big data? Why Hadoop and Spark? Drawbacks with the current databases and Hadoop and Spark, Hadoop components, right? Hadoop components and Hadoop advantages. Before that, like before Hadoop components, what are Hadoop advantages? Hadoop components, Hadoop ecosystem components, right? And Hadoop and Spark job market. Hadoop and Spark job market, right? Yes. Okay. So as part of this course, we'll be learning both Hadoop and Spark, right? Spark with Scala implementation, right? By default, Spark built by using Scala language. Most of the APIs will say Scala. Fine. What is big data, right? What is big data? Big data, right? The name itself saying, right? Huge volumes of data, right? Huge volumes of data. Today, if you observe, right, how data is getting stored, like the data storage units, right? KBs of data, MB, GB, gigabytes, terabytes, petabytes, exabytes, zettabytes, yottabytes, sottabytes, so on, right? Yes. So you should have seen KBs of data, MB, GB, TB, or petabytes, or exabytes, zettabytes, right? But you should have like TBs of data up to this KB, MB, GB, or TB you should have seen. But do you think like petabytes or exabytes of data is getting generated in the current real world? You know, like MB, GB, even TBs of data, right? But do you think like petabytes of data, the exabytes of data, is it getting generated? If so, examples of petabytes of data generation, one petabyte equal to 1024 TBs. Already 1 TB is a large storage unit, right? 1 petabyte, yes. 1024 TBs. Already 1 TB is a large storage unit, right? So do you think like petabytes of data, is it getting generated? Means yes. So if you take example of a bank, like take a bank like SBI, right? Or HDFC. Okay, SBI. Within the city, you see like hundreds of branches for a bank like SBI. Within the entire state, we see like thousands of branches for SBI. within the entire country, lakhs of branches for SBI, right? So this lakhs of branches, again, millions of customers making multiple transactions, right? Per hour, per day, per week, per month, and year, right? Each and every transaction need to be stored, like huge data getting generated. Okay, not only like forget about this bank, everyone are aware about social media like Facebook, right? It's Facebook. What is the data generated by Facebook in a minute? Facebook has got users not only within the country, it has got users throughout the world, right? Millions and trillions of users for Facebook. In a minute, how many posts and videos are getting circulated? What is the data generated by Facebook in a minute? It's not MBs or GBs, like huge data, right? Not only like Facebook, right? Today, if we talk about any application generating huge data, any application, talk about any application, right? Yes. For example, in a minute, how many FB, what is the data generated by Facebook in a minute? What is the data generated by Twitter, right? Facebook, millions and trillions, right? And what is the data generated by Twitter? Hmm. Data generated by, what is the data generated by Google, right? Everyone just querying in the Google, right? So what is the data generated by YouTube? Everyone uploading your YouTube videos upload, right? What should be the storage capacity to store all the videos, and millions and trillions of users using email messages? What should be the capacity to store this email messages, right? Okay, next, like bank transactions, telecom transactions, yes, e-commerce sites like Flipkart, Amazon, right? Everywhere you see like huge data is getting generated today. So as day by day data is increasing enormously, we need to have proper storage systems, right? For storing and handling the data and processing it accordingly as per the business logic, right? Currently we have some databases. Currently we have databases, right? Like Oracle, MySQL, right? We have got databases like Oracle, MySQL, DB2, SQL Server, right? Yes. So these are used for online transactional processing, OLTP, online transactional processing, day-to-day operations, right? But we have got some specialized databases. We have got some specialized databases, right? Yes. Used for data warehouse purposes like Teradata, if you heard about like Teradata, Netezza, right? Teradata, Netezza, Vertica, right? These are used for data warehouse purpose, right? DWH. OLAP. All right. Oracle, MySQL, DB2, SQL Server, Teradata, Netezza, and Vertica for data warehouse purpose, OLAP, right? So, but these databases are specialized databases. They can handle data up to some extent, but they cannot handle like a TBs or petabytes of data, right? So, like this database, like GBs of data, specialized database like TBs of data, but beyond that, petabytes or unlimited data storage or processing, it's not possible, right? So, as a solution to all these storage and processing levels, right, we have got a framework Hadoop, right? Both for storing and for processing. Later, I'll come back to the services of Hadoop, right? So before that, so you need to know like how this data is getting generated, what are the different sources and different types, right? Before I come with the services of Hadoop and the advantages of Hadoop as compared with other technologies. That's right. So if you take, this is the data available in the current real world. So this is the entire data in the current real world, right? Yes. This data has been generated from the last 50 years. Assume this is the data from 1972 to 2022. If you talk like last 10 years from 2012 to 2022, last 10 years. Okay, and if you observe the previous 40 years, right? Only 20% of the data you see from the last previous 40 years as compared with 80% of the data got generated from the last 10 to 15 years. So the reasons for a huge data generation, right? Because of usage of technology, right? Because of usage of smartphones, right? And because of usage of internet. Today, everyone carrying internet, right? Yes. So because of this usage of internet, smartphones and technology, previously, if you see in 1990s, you used to have floppy disks, just 1.44 MB of size, right? Later it got CDs, DVDs, right? Yes. But as day by day it is increasing, the storage capacities also need to be increased, right? So from where this data is getting generated, what are the main sources from where this 80% of the data is getting generated from? Mainly three sources, right? Mainly three sources of data. Social data, machine data, and transactional data. Social data, machine data, and transactional data. Social data means the data which got generated from social sites, websites, right? Like Facebook, Twitter, all this, right? And machine data means the data which got generated by reading or scanning the barcode scanners and RFID chips, right? Such kind of data we call it as machine data, which got generated by reading or scanning the bar. Means if you go to any shopping mall, for the items you purchase, you get a bill getting generated, right? Means by reading the barcodes and scanners, such kind of data we call like machine data. And transactional data like day-to-day operations, bank transactions, telecom transactions, right? Yes. And if you talk about its types, the data is going to occupy three types, right? Three types of data, mainly of three types. You can see that like a structured data, you can see like structured data. Structured data, semi-structured, right? And third, like unstructured data. Structured data, on semi-structured data, and unstructured data, right? Structured, semi-structured, and unstructured, right? Yes. Structured data, right? Structured data. Yes. Data which is organized in the form of rows and columns in a structured format. Data which is organized in the form of rows and columns in a structured format. Right. Like Excel sheets, DB tables, database tables, Excel sheets. Semi-structured, right? Semi-structured data. Which is not fully structured, which is not fully unstructured, right? Like XML, JSON, right? And unstructured means like chart messages, articles, images, videos, etc. All comes as unstructured. Structured data, semi-structured and unstructured, right? Database tables, Excel sheet, semi-structured data, unstructured data, images, videos, all this, right? Yes, three types of data. Okay. So now, as day by day data is increasing enormously, right? We need to have some proper storage systems and proper processing systems, right? For storing huge data and processing this huge data, right? So as a solution to all these storage level problems and processing level problems, we have got a framework called Hadoop. Hadoop meant for two things, mainly for storage and for processing. It's meant for storing the data. It is meant for processing the data, right? Yes. If you talk any technology, it is meant either for storage or for processing. If you talk like C or C++ or Java, .NET, all this, they are meant for processing. And if you talk like databases like Oracle, MySQL, DB2, all this, right? SQL Server, they are used for storage. They are meant for either storing or meant for either processing. But Hadoop combines both storage and processing. It is meant for both storing and for processing. For storage, we have got, we doesn't, for storage, does Hadoop use any database for storing its data? No, I am saying that there are some drawbacks, still drawbacks with the database. So despite of those drawbacks, still Hadoop doesn't go with the database for storing its data. It is going with a file system called Hadoop distributed file system. And for processing, is going with the execution model called as MapReduce, right? Or Spark. Right. So this is what Hadoop providing two services, storing and for processing. Storage like HDFS, processing MapReduce, right? If you take big data as a problem, right? If you take big data as a problem, like you can say Hadoop as the solution. You can say like Hadoop as the solution for it. Okay, if you take big data as a concept, you can say like Hadoop as the implementation, right? So yeah, generally what we do using data, right? So you generally use data for storing and for processing, right? So generally, when we get problem with storage, when we got problem with the storage, when we get problem with the, see what is big data, a problem, when you get problem, when you are going to get the problem means whenever there is a storage issue, you say it's a problem in storage. And when you are processing huge data in terabytes or petabytes of data, normal the C, C++, Java, they are going to process like small amount of data, right? That if you go, when you process like huge amount of data, like bulk of data, right? We get problem with the processing. We call the data as the problem data. This problem data is nothing but we call it as like big data, right? Big data. Okay. So where the problem started with data. Data has got experience, data has got future reference, right? So Hadoop will be the solutions for the all the data related problems. For storing it and processing it, right? For data management, we say, right? Data storage and processing. So what kind of problems? What kind of problems we see right here? What kind of problems? First, like 4 V's we can say. 4 V's we can say, right? 4 V's. First one is volume related. First one is volume. Second is value related data. Value related means quality of the data. Next is like velocity. Velocity means speed and processing. Speed and processing. And fourth one is like variety, right? Variety. Variety means structured, unstructured, or semi-structured. Right? Okay. So if we take big data like a problem, we can say like Hadoop is the solution, right? Yes. Okay. Fine. Coming back. Right. So why databases are not used as a storing Hadoop's data? Why database are not used as right for storing Hadoop? Drawbacks with the current databases, right? So hope you understood first the what are the service, what is Hadoop, what are the services of Hadoop, right? And why Hadoop. I'll come back to the Hadoop advantages. Before that, what are the drawbacks you observe? Drawbacks. Drawbacks of current databases. Drawbacks with current databases means first mainly the drawbacks with the databases is like limited storage. They can store data, not unlimited or huge data. Limited storage in GBs or in TBs. And secondly, most of the databases, there is no parallel processing in most of the databases. No parallel processing in most of this, right? Yes. And the drawback, see, as I'm saying that volume, if volume increases, right? Volume increases, speed decreases, I'm saying. Speed decreases, I'm saying, right? For example, if you take an SQL query, right? Select total amount from sales, total amount from sales one, right? Select total amount from sales one. Think that you got some 10 records in it. 10 records. Select the total amount from sales to 1 lakh records. Select total amount from sales one, 10 to total amount from sales to 1 lakh records. Select total amount from sales 3, right? So if you have got 1 crore records, so sales 1, sales 2, and sales 3, 1 crore records. Total amount from sales 1, total amount from sales 2, total amount from sales 3, right? 10 lakh, 10 records, 1 lakh records, 1 crore records, right? Yes. As volume increases, speed decreases, right? Yes, volume increases, speed decreases. Total amount from sales 1, sales 2, and sales 3. 10 records, 1 lakh records, and 1 crore records. Which query is going to execute faster among these three? Total amount of 10 records, total amount of 1 lakh records, total amount of 1 crore records.
Total amount of 10 records.
Total amount of 10 records, right? Yes. So here, if you observe, query to query, as the volume increasing, speed decreasing, right? So here, and I was saying there is no parallel processing, and one more drawback, complexity increases, right? Speed decreases. Okay, for example, if I take the same, select sum of amount from sales 1, if I take the same query, okay, now see this, if complexity increases, okay, first one is sum of amount, see this second, right? So average of amount from sales 1 only. Next, standard deviation of amount from sales 1 only, right? So which query execute faster among these three? Standard deviation of amount. Average amount is a two-step process, right? First sum to be calculated, next average to be calculated. As compared to the first query, second query, as compared with the first query, second query is going to take time, right? And as compared with the second one, standard deviation takes lot of internal processing, right? Lot of internal processing required, right? Yes. Yes. And here, major drawback with the databases, right? Databases can handle only structured data, They cannot handle unstructured or semi-structured kind of data, right? They can handle only structured data. So for example, if you take this example, right? For example, I want to take reviews for a particular movie. Reviews is a table. Think that a table structured, you got some columns like users and review. User one saying that movie is good. User two saying movie is not good. User three. Okay, fine. So before that, right? Yes. Okay. To take reviews for a particular movie, first assume that if it is in a structured format, assume it is in a structured format. User and review. User one, user two, user three. In this way, 100 users giving the review. User one saying if the movie is good, saying 1. If the movie is bad, saying 0. If movie is good, 1. If movie is bad, saying 0. They are giving the feedback in the form of reviews in the form of zeros and ones. Can you write an SQL query to count the number of zeros and ones? Can you write an SQL query to count the number of zeros and ones? Count aggregation. Review wise, select single grouping, single aggregation. Review wise, select review wise count. I want count star from table. Which table? Reviews table. From reviews table, group by. Review wise count star from reviews, group by review. Okay, what is output? 1 and 0, right? 90 people saying the movie is good, 10 people saying the movie is bad. Okay, you got the counts, right? But generally, reviews won't be given in the form of zeros and ones, right? So they will be given in their own text format, like first person saying movie is good, second person saying movie is bad, movie is not good, third person. So in this way, they are giving that review in their own text format. Can you write an SQL query to count the number of goods and not goods here? Can you write an SQL query to count the number of goods and not goods? Not possible. Even if you say keyword count based on this keyword good, it gives wrong computation, right? Because even not good is having good within it. So databases can handle only structured data. They cannot handle unstructured or semi-structured kind of data, right? Yes. Now, see, coming to this Hadoop advantages, right? Hadoop advantages. Unlimited data, mainly first one is unlimited data storage. Unlimited data storage. Secondly, very high speed processing, very high speed processing. Very high speed processing. Very high speed processing, right? And can handle all varieties of data, can handle all varieties of data. And it's an open source, no licensing required. Open source, no licensing required, right? So mainly the major advantage, right? Unlimited data storage and very high speed processing, huge data and processing in quick time, can handle all varieties, structured, unstructured, semi-structured. The biggest challenge is like how to handle the unstructured kind of data, right? So in Hadoop and Spark, right, we can just deal with unstructured kind of data processing also possible, right? So for example, Yahoo has conducted a test to check the speed of various databases. It has taken a table, Yahoo has taken a table of 100 TB, right? It has taken a table of 100 TB consisting of 1024 columns. Yes. So here the task was sorting based on 16 columns. Sorting based on 16 columns. So time taken by different databases, right? Time taken first, like Oracle has taken nearly 3.5 days, right? Secondly, like MySQL has taken nearly 6 days. Teradata, which is specialized database used for data warehouse purpose, it hardly has taken 4.5 hours only. It has just taken 4.5 hours. Netezza, another specialized database, right, used for data warehouse purpose, it has just taken 3 hours. And Hadoop has just taken 3.4 minutes, right? Has just taken 3.4 minutes. So where this Oracle MySQL has taken days, Teradata and Netezza taken in hours, Hadoop taken in latest version of Hadoop taken just 1.2 minutes. That is what Hadoop proven in the market. Processing point of view, not only processing point of view, storage point of view also. Why Hadoop only can handle huge data, unlimited data? Why not other databases? Right?
Sir, I have a question.
Yes.
So basically, the time frame that you mentioned, is it for processing the data or just to storage the data?
Is for handling, see, sorting the data based on 16 columns, right? So to perform this operation, sorting based on 16 columns, the task was, right? For performing this task I was talking, right? So sorting, so there are many columns. Generally, we sort based on a single column, right? like based on rank or based on age, we'll be sorting. Based on 16 columns, sorting should happen, right? So for that task, right, what is the time taken by these things, right?
Okay, okay, got it, got it.
So you can see this, right? You can just check this example. Even you can see in the websites, right? Now, what is the processing speed of Hadoop as compared with the other things? So, but as compared with Hadoop, right? Even Spark has got very high speed processing, very high speed processing. Spark has got, right? So Spark, because of in-memory computation. In-memory means storage happening within the memory, processing also happening within the memory only. Means data gets stored within the RAM, processing within the RAM, both. But generally, storage happens in the disk and processing, right? But here, storage and processing both happening within the RAM level, memory level. That's why we say like Spark is a in-memory computing system, in memory level. Everything happens within the very high speed processing, right? So as compared with Hadoop also, Spark has got very high speed. Both Hadoop and Spark both combinedly used for. So for this currently like for data engineering, right? So both Hadoop, like we have got some components like a HDFS for storing data and Hive for data warehouse kind of an environment, Scoop for import export operations, right? And NoSQL database and Spark, right? So what is the course content I'll be discussing as part of this, right? So some components are outdated, but I'll be just discussing on the components which are mostly used today, right? Observe this. Big data Hadoop, right? Introduction, what is big data Hadoop, sources, types, comparison, challenges, advantages of Hadoop, right? Hadoop distributed file system, HDFS, right? Hadoop doesn't use database for storing. We need to just see in brief about this file system, right? HDFS architecture, what is name node, data node, secondary name node, right? Metadata management, storage replications, fault tolerance, right? If any machine goes down, then how Hadoop is going to map reduce execution model. And next, like coming to Scoop, right? How to import and export operation from databases to Hadoop, Hadoop to databases back after processing, right? Yarn, yet another resource negotiator. We got a lot of architectural changes, right? From Hadoop 2 version onwards as compared with the previous version, where there was some architectural drawbacks where everything got rectified. Pig, previously it was much used, right? But just now it is very less used when okay, Hive, but Hive is a kind of data warehouse kind of environment, right? It is a kind of data warehouse kind of environment mostly used. Hive is the important component of Hadoop, mostly used in most of the project, right? Here we uh, handle the data, we make data structured and create tables and perform querying. And also we have got many types of tables like internal, external tables, partition, non-partition tables, and also working with XML data, JSON data, unstructured data, URL weblog data processing, right? And working with UDF, UDAF, UDTFs, right? User defined functions, user defined tabular functions, and kind of partitioning, static partitioning, dynamic partitioning, multi-column partitioning, bucketing in Hive, indexing in Hive, performance tuning mechanisms, right? And also like NoSQL database as a Hadoop developer, right? You need to have knowledge of at least one NoSQL database, right? Okay, NoSQL, not only SQL, right? We are discussing HBase, right? HBase is Hadoop database. So apart from this, I'll also give knowledge on streaming data and technologies like Flume, Kafka, right? Streaming means data which keeps on generating, means data which keeps on incrementing, right? Such kind of data, like how we can capture, right? Using components like Kafka and Flume, Spark and Scala, right? Trust. So Spark implementation using Scala. Spark by default built using Scala. All the APIs we see using Scala, right? Scala, first I'll be discussing Scala programming before I go with Spark. Scala basics, Scala data types, Scala variables, typecasting, Scala control structures, Scala collections, Scala lists, arrays, tuples, map transformations over the collection, map, flat map, filter, eliminating nulls, Scala functions, right? And Spark core programming, I'll be discussing like Spark core programming, So defining Spark features, advantages, RTD computations, persistence options, memory only, SCR, core computation, fault tolerance mechanism, different ways of creating RTDs and groupings and aggregation, single and single grouping, single and multiple aggregation, multiple and single aggregation, right? Yes, various actions and transformations, right? And one by one action and transformations in brief, in depth, right? We don't need to write huge codings. We have got inbuilt transformations and actions, and Spark SQL, right? How to make the data structured, working with data frame APIs, later like data sets API, RTDs, working with the SQL statements, Hive statements, MySQL integration, right? All this, and deployment modes, local and cluster mode, and applications like stages, tasks, driver and executors, and Spark submission by using Eclipse IDE, IntelliJ IDE I'll be showing you, and I will show you on using build tools like SBT build tool, Maven build tool, right? Yes. And also knowledge on Spark and Cassandra I'll be providing. This is in brief, right? So it's an offer batch, right? So where both Hadoop and Spark is going to be covered. So from tomorrow also people can attend the session to see more on this, how exactly the data storage and processing happens within, right? Fine. No need to worry about the software, other things, right? I'll be just forwarding you within this Google Drive. You can just download and I'll demonstrate how to work. You can see all the components, right? Hadoop, Pig, Spark, Pig, Spook, Flume, Kafka, HBase, Spark, Scala, PySpark, all this you will be seeing the software and work with it. For any configuration, I'll be giving multiple images, right? For people with a low system configuration, other things, right? Yes. So every session will be video recorded. You will be getting the recorded video also. If you miss the session also, you'll be getting the recorded video because of some job timings or because of some ill health, right? If you miss the session also, you immediately every day the recorded video will be forwarded to your Google Drive. I'll be forwarding the notes to your Gmail, right? So yes, so both Hadoop and Spark, right? So nearly I'll be spending nearly 70 to 75 hours in that, which includes more than 60% of that I'll be taking on Spark only, right? Out of 70 hours, right? Nearly 45 hours I'll be spending on Spark, nearly like 25 hours on Hadoop, right? So where Spark is much used today, right? And Hadoop components like Hive, Scoop, HDFS, these things, MapReduce, these things I'll be discussing. Any queries from your side, anyone, right?
Sir, what about I really appreciate for the course that you just proposed. Basically, I just wanted to ask about the placement. Means, will you provide any type of placement here? Means,
See, only
what would
thing
be the
is,
job opportunity for the same?
sir, is people who come for big data, right? So it's a not a kind of technology like you are updating with big data technology, right? People with big data technologies, if you have got command on that, right? Definitely you can just Google and check, right? Even if you see the salary packages for big data, Hadoop and Spark as compared with other technologies, it will be more than, see, 1.5 times more than the other technologies, right? See the packages for this. Means at the same time you require uh, the command on that technology, right? So that if you go to an interview, if they ask, right, you need to be able to, means you need to have the command on that. So that command we are going to see within this, right? We are spending like 70 hours, not like 45 hours course. So we'll be discussing about each and every functionality with many working examples, right? So once you can go for interview, like a typical 4+ years of experience person, how much knowledge he has, that I'm going to provide you, right? During this course, step by step. It's not written like everything I'll be typing and showing you how to deal with the different APIs of this Hadoop and Spark.
So, will you cover any project in between the syllabus as well?
So at the last, I'll be showing you one project flow, right?
Okay.
So
So
in the middle, like we'll be discussing many scenarios in POCs, right? In different components, right?
okay. Okay, sir. Sure. No problem. So basically, I wanted to ask you one question, sir, again. I'm a system administrator right now. I'm currently working at one of firm. So I'm having a 3+ years of experience. So will this course helpful for me to get transited into big data?
You're working as a
Senior technical support associate.
Okay. So
So
one
I
thing,
am currently I'm in user provisioning. You can say
so,
identity access management.
so one thing, some of you are asking the prerequisites also, right? So
Uh-huh.
the first thing is basic SQL required, basic Linux required. Even if you doesn't have basic Linux knowledge, right? For 2 days, I'll be just briefing you about all the basic Linux commands, not all the things. Basic SQL is required, and remaining all I will take care of about things, right? The only thing is you need to do the practicals at least 1.5 hour, 2 hours per day. So to get a comment on that, right? If any queries at the start of the session itself, you can ask me up, right? So you need to just every day, if you do the practicals, it looks very simple and easy to understand, right? Fine. So yes, anybody can update, right? But basic Linux, basic SQL required for this. And anyhow, I'll be discussing Scala language as part of this course only. And Hadoop and Spark also, everything in depth, in brief, I'll be discussing. You can just go through the course structure also. We see like deep in this. Apart from this, I'll also give knowledge on this NoSQL database. I said I'll give knowledge on one SQL. See, one storage like HDFS processing, right? I'll be discussing nearly 4 processing components like Spark, MapReduce, Hive and Pig, 4, and one NoSQL database I'll be covering as part of this, like HBase. And also in Spark, I'll also show one more NoSQL database like Cassandra, and streaming, like 2 streaming technologies like Flume and Kafka, what I'll be discussing as part of this, right? So this is more than enough, right? We had knowledge on the entire big data, right? Yeah, if anyone means if anybody wants, like even I've got some weekend sessions available for those who got for Spark with Python implementation, PySpark. Here we are seeing Scala implementation. That Spark remains same in both, but only the language is different. But mostly Scala means both are used. I'm not saying like both are used, but by default, the Spark built using Scala. Yes. Okay. So this, if you check in the Google, if you check in Google, right, the jobs for Spark and Hadoop, you can just come to know even the packages for it. So great demand in the market because of huge data generation. We require tools like some appealing tools, right? Some where we can process the data in quick time. Today, industry is expecting quick results, right? We need to have some processing technologies which can process huge data in quick time, right? So Hadoop and Spark is one among that, right? So it has got great demand in the market. So even for even a typical data scientist depends on this data engineer, right? For just extracting and transforming these things, right? Accordingly as per the business logic. Okay, yes. So even tomorrow we can attend the session, right? To see more on this, how exactly the data storage processing happens. Fine, you can follow the same link, same time tomorrow, right? Fine. So if I'm done with the queries, right, then I'll sign off for now. Meet you tomorrow, same time, right? 5 o'clock.
Sure, sir. Thank you. So any offline batch available for the course?
Offline, no, we see very less people, right? No, only online. Yes.
Okay. Okay, sir. Fine. And will you cover the AWS as well?
No, at the last, I'll be giving the knowledge how to work on this AWS also, right? Yes.
Okay. Sure. Thank you. I'm really sorry. I might be you thinking that I'm asking you more question,
No,
but these
no,
are the questions.
no, I want sessions to be interactive, right? That's what I'm asking. You'll be kept in
Ha,
unmuted.
ha, ha.
So everyone, you are
Mhm.
welcome to ask queries. I am expecting that queries from your side. So even in the during this sessions also, right? It's not me speaking out, right? I want the sessions to be interactive. You keep on
Ha, ha,
responding
correct.
for every statement I type, right? I will be expecting as it's a demo session as I was speaking, but in the regular sessions, I want the sessions to be interactive, right? If I take any problem statement, right, you will be just asking that you will be step 1, step 2, step 3. First one example I'll show you.
Correct, correct.
Next one, second example, I'll asking you like what is step 1, step 2, step 3. So that based on that, you will get an idea what are the steps to be followed in this, right?
Mhm.
Yes.
Okay, sir. Sure. Thank you.